Algebra 2, Chapter 3, Section 2, Solving Inequalities. A value of a variable that makes an inequality a true statement is a solution to the inequality. For instance, if I give you the inequality x plus 2 is less than 3 and say, is x equal to 3 a solution? 3 plus 2 is 5. 5 is not less than 3, so the answer is no. What about x equals minus 1? Minus 1 plus 2 is 1. 1 is less than 3. Yes. What about 1? 1 plus 2 is 3. 3 is not less than 3. It's equal to 3. So if this were less than or equal to, it would have been yes. Generally, when we're asked to solve an inequality, we're wanting to find the set of all possible solutions, and we need to describe that set. There is no need for us to use a formal set theory in this class. It's just Algebra 2. We don't need to try to formally define the set of all solutions. But we need to indicate in some manner what the set of solutions is. So, if we want to indicate that all the real numbers are solutions between -2 and 3, but we have an equal to 3. So this slide's actually a little bit wrong. So if we wanted to indicate all real numbers greater than -2, we wouldn't put the bar here. And equal to 3, we would put the equal sign here. We would write -2 less than x less than or equal to 3. If we need to describe more than one disjoint area of the number line, we can do so by indicating in this way with an or. So we can say x is less than -2 or x is greater than or equal to 3. So let's solve a few inequalities for practice. So we need to solve 3 times x minus 12 is less than 0. Well, we can add and subtract both sides of an inequality just like we can with an equation without changing any truth to the inequality whatsoever. Adding 12 to both sides, we get 3x is less than 12. Dividing by 3, we can divide by a positive number with no problems. We see x is less than 4, and that's a way of describing the set of all solutions, so we'll just box that. Solve 30 minus x is less than 50. Sorry, greater than 50. So if we go ahead and subtract 30 from both sides, we get 50 minus 30 is 20. But now we have a problem. We have a negative x, and multiplying by a negative will cause a problem. We could demonstrate that actually by solving this inequality without doing a multiplication. Instead of subtracting 30, let's subtract 50. 30 minus 50 is minus 20. And now add x. And we get minus 20 is greater than x. And that is the right answer. And if we flip this inequality around, so x is first, we have x is less than minus 20. Because if minus 20 is greater than x, x must be less than minus 20. And so that indicates what we need to do if we're going to multiply. If we multiply both sides of an inequality by -1, we have to flip the inequality the opposite way. So instead of it being greater than, it needs to become less than. And if it were an equal, the equal stays the same. So the answer is x is less than minus 20. So as I already mentioned, this previous example shows we must take great care when multiplying or dividing by a negative in an inequality. In such cases, the inequality must be flipped. So let's see another example of this. Solve this inequality. First thing we should do, subtract 6. So that would make us have 4 minus 6 is minus 2. Minus 3x plus 2 is greater than or equal to x. Now let's distribute this negative. Minus 3x minus 2 greater than or equal to x. Minus 2 is minus 4. Subtract the x, we get minus 4x minus 4 is greater than or equal to 0. Adding to 4, minus 4x is greater than or equal to 4. Now we need to divide by negative 4 to get the answer, but when we do so, we divide it by a negative. We have to flip the sense of the inequality. So 4 divided by negative 4 is negative 1, but instead of it being greater than or equal to, it's less than or equal to. And that's the answer. We could check solutions to inequalities, but it's not as easy to do. We could pick a value that is less than or equal to negative 1 and plug it in and make sure we get a true statement. So let's just try that. Let's plug in negative 2, which is less than negative 1, into the inequality. 4 minus 3 negative 2 plus 2, is that greater than or equal to 6 minus 2? So we have 4 minus 3 times negative 2 is negative 6 plus 2 is greater than or equal to 6 minus 2 is 4. 4 minus 6 plus 2 is minus 4. And 4 minus negative 4 is 4 plus 4, which is 8. 8 is greater than or equal to 4. Check. Now, beyond just solving inequalities, we might use inequalities to help us describe when a solution is positive, negative, or 0. So let's do an example of applying that idea to a problem. So for what values of x is the expression 2x squared minus 3x minus 2 positive? So we can write an algebraic statement about this. For it to be positive, it must be greater than 0. Let's take a moment to talk about that. Positive is greater than 0. Negative is less than 0, which means 0 is special. 0 is not positive, and 0 is also not negative. It's neither positive nor negative. If you want to describe in English all the numbers that are less than or equal to 0, you would need to say negative or 0, or most times mathematicians will say non-positive to mean both negative and 0, or non-negative to mean both positive and 0. So here, positive means greater than 0. Positive is another way of saying an inequality. So when is this statement positive? To figure this out, we need to factor the left-hand side. To factor the left-hand side, we need to figure out what numbers, so 2 times negative 2 is negative 4, what two numbers multiply to negative 4 and add to negative 3? Well, minus 4 times 1 is negative 4, and minus 4 plus 1 is negative 3. So let's split the middle into negative 4 and 1, which we don't have to write 1. Factor this to 2x minus 2 plus x minus 2 is greater than 0, which leaves 2 plus, sorry, 2x. Took out a 2x in common here. 2x plus 1, because there's only a 1 here, times x minus 2 is greater than 0. So for this whole quantity to be greater than 0, either this quantity must be greater than 0, or this quantity must be greater than 0. Sorry. For it to be greater than 0, positive, both this quantity, 2x plus 1, has to be positive, and this quantity has to be positive, x minus 2. Or there's another case, both of them can be negative. So we have kind of two things going on that might happen. So let's first think about both positive. If they're both positive, that means we can write these two inequalities, 2x plus 1 and, sorry, 2x plus 1 is greater than 0, and x minus 2 is greater than 0. So let's see if both of these can be true at the same time. 2x is greater than minus 1, and x is greater than 2 by adding 2 to both sides. Dividing by 2 on this left inequality, we have x is greater than negative 1/2, and x is greater than 2. Well, if we think about a number line, it may help us here a little bit. Here's 0. Here's minus 1/2. Here's 2. So the first statement is all the numbers bigger than minus 1/2. Second statement is all the numbers bigger than 2. Where do those overlap? Where are they both true? And, well, when x is bigger than 2. This is kind of superfluous and unnecessary. So this half of the logic got us x is greater than 2. But there's another case. Either they're both positive or they're both negative. If they're both negative, then we have 2x plus 1 is less than 0, and x minus 2 is less than 0. Solving, we have 2x plus 1 is less than 1, and x is less than 2. X is less than 1/2, and x is less than 2. Well, here the x is less than 2 is superfluous, so we have x is less than 1/2. So here we have two disjoint parts of the number line. Our answer is x could be less than 1/2, or x can be bigger than 2. And all those values on the number line, less than 1/2 or greater than 2, will make this expression positive. We can check our work here by taking some of the values where it should be positive and checking. So x0 is less than 1/2, so at 0, this should be positive. So 2 times 0 is 0, minus 3 times 0 is 0, minus 2 is all we're left with, which doesn't check out. This is not good. So let's think about what we did wrong. So 0 is less than 1/2. Oh, here's what we did wrong, right? Minus 1/2. So this is a good example of why we should need to check our work. So we need to subtract 1, not add 1 to both sides. When we go too fast, we make mistakes. Minus 1/2. Minus 1/2, which matches the work we had over here. So that makes sense. And we see that, in fact, when we put it in 0, it's not positive, it's negative. So that couldn't have been right. So now that we fixed our answer, let's go back and check again. Now, what if x is less than minus 1/2? How about negative 1? Let's check negative 1. 2, negative 1 squared, minus 3 times negative 1, minus 2. Negative 1 squared is 1, gives us 2. Negative 1 times negative 3 is plus 3, minus 2. 2 minus 2 is 0, so we're left with just 3. And 3 is positive. So that checks. Now let's try the number greater than 2. Let's try 3. So 3 squared minus 3 times 3 minus 2. 2 times 3 squared is, so that's 9/18. Minus 9 minus 2, which is 7. And 7 is less than 0. So that checks out. I'm sorry, 7 is greater than 0. We're looking for positive numbers. Positive numbers, not negative. So it does check out. So this is good.